All right. So thanks to ICN for the for inviting me, and thanks Mr. Call for the introduction. And really delighted to moderate this session. What an opportunity this is for me, and really thankful for giving me this opportunity. And to audience, this session brings to us a team of illustrious members of the industry who themselves are authorities in their own domain. And I hope that all the discussion we have here that will prove to be immensely value adding for all of us. This session covers the discussion across the value chain of different colors of hydrogen, and I would proceed in a manner. First, I would like to talk about the current status of the technology. Then we would go on to the discussing the extent of the opportunity. Then I would go on to maximizing the maximizing the value which we derive from the hydrogen. Then I would take the discussion to bridging the gap between the different colors of hydrogen, and then competing technology. So and I would intend to finish this discussion in about 1 hour, and would leave about 10-15 minutes for open house Q&A. And I would request panel members to respond to all the discussion agenda points maybe in 3 to 4 minutes, and not elongate. I know all of you can take maybe hours on any agenda point which is in your domain, but then please restrict between 3 to 4 minutes. And if you have any question, please feel free to type in the chat box. And depending on the questions and the expanse of the question, and also the discussion we have had till then, I would take up that question if that question remains unanswered till that time. And let's all leverage the opportunity to have discussion with such an illustrious luminaries of the industries. And towards the end, we look forward to having the open house question discussion from the house. With this, I would like to start the discussion. And Mr. Lele, I would like to first come to you. And I know the agenda I'm going to put across to you. You can talk on that maybe for days, but then I would want you to make it crisp and just respond in few minutes. So, and as we all know, hydrogen being a rapidly developing area, we would like, and my audience would like to hear from you the status of the technology for the storage and logistics. And also, what would be your view on the public perception of hydrogen? Because whomsoever I talk to, general public, maybe who is new to hydrogen or who is not maybe as well versed with hydrogen domain as a few of us are. So the perception I get to hear is that it's very dangerous because of the reason that the pressure and temperature it is transported and stored at. So it feels quite dangerous. So would you like to comment on the status of the technology for storage, logistics, and also from the safety perspective? How do we counter this public perception of dangerousness?
Thank you, Mr. Raman. You touched upon the most important part of the value chain of hydrogen, because this is the more difficult part of the whole hydrogen value chain. So I'll be very brief. I think in terms of storage, if you were to classify the technologies, we can roughly classify them as gaseous forms, liquid forms, and solid forms of hydrogen. The gaseous forms is basically what is today most widely used, which is in the compressed gas state. Hydrogen being very low density, therefore it has to be compressed if you want to store sufficient amounts of hydrogen in any given volume. So compressed hydrogen cylinders, which are typically carbon fiber composite cylinders, so that you make the storage capacity significantly higher. Those are the most popular forms of hydrogen storage and transportation today. So these are, as I said, carbon fiber epoxy cylinders. Hydrogen is stored anywhere between 100 to 1100 bar, and different applications need different pressures of hydrogen. So this is the most popular form of storing and transporting hydrogen. The liquid form of hydrogen is essentially either you liquefy hydrogen. Hydrogen, as you know, has a very low temperature for liquefaction, something like minus 250 degrees C. And so you need to have sufficiently high cryo conditions to liquefy hydrogen and store it. Liquefaction gives you much higher gravimetric capacity, which means in the same volume you can store a lot more hydrogen. But there's a energy penalty of liquefying it. The second type of liquid is in form of what is called the LOHC, that is the liquid organic hydrogen carrier. So it's a liquid, but hydrogen is not liquefied here. Hydrogen is stored in this molecule. So hydrogen is actually stored in the form of a chemical part of that molecule. And then you have to extract the hydrogen out from that molecule by some kind of chemical process, typically a dehydrogenation process. The most favorite liquid organic hydrogen carriers are toluene, what's called 2,3-DBT, or even methanol and ammonia are sort of liquid carriers of hydrogen. So that's the second form of hydrogen carriage. The third is the solid state hydrogen. And this doesn't mean that hydrogen is further cooled and solidified. It means that hydrogen is stored in some form of solid mass. These could be metal hydride, which is the most common one. And it also could be other forms where hydrogen is physisorbed. So it is physically absorbed in the materials. The ones that people are looking at are metal organic frameworks and covalent organic frameworks and so on. So these are the other solid forms of hydrogen storage. You could have combinations of these, but typically these are the three more popular ones. And of all of these, the compressed hydrogen is the most popular. So those are the technologies available today. You asked me about safety. I would only say that when India started using CNG several decades ago, there was the same kind of apprehension from public that we are carrying a bomb of natural gas in our vehicles, and how safe will that be? But if you look today, nobody even thinks about it. In fact, people line up for hours in queues to refill their gas, which means that it is not only safe, it also is a very viable and attractive way of carrying energy. The same, I believe, will happen with hydrogen. From a purely technological perspective, the high pressure hydrogen cylinders are very robust. They have been tested uh, by companies that are known for their safety standards. There are well known standards that are available globally. India is on its way to harmonize our standards with these global standards. So the technology is very much in place, has been thoroughly tested. Standards, regulations are in place, and we have organizations like PISO which will do the all the due diligence to make sure that cylinders are properly tested before they are adopted into our vehicles. So it's only a matter of perception. There is no issue with technology. Of course, it doesn't mean that I'm trivializing the issue. Hydrogen is a hazardous material. It's a highly explosive material. So all with due care taken and with the right technology adopted and with the right regulatory processes in place, I think hydrogen will, people will overcome this kind of apprehension, and hydrogen will get adopted in the future. So I'll keep it simple and straight, and let the time be available for other panelists.
Right, right. So, if I take your word, it's the safety perception. It is just limited to perception, and there is no scientific reason to be scared of the pressure and of the temperature at what hydrogen is carried. And I would agree with you, because in the newspaper, whenever I read, and there is a automobile company who manufactures hydrogen vehicle, and their statement, I read that the safest part of the vehicle is where the hydrogen cylinder is stored. So maybe that gives us enough comfort. Thanks, Mr. Lily, for this. But on a follow-up question, and just a few next seconds, is you spoke about various means of transportation. If I bring in the cost, and you said that the compressed hydrogen is the most popular one, which is being widely viewed. So, if I bring in the cost perspective, would you still believe that that mode would remain most popular, or it would be most prevalent?
Yeah, so one part of the gaseous hydrogen storage and transportation that I missed out was is eventually, pipeline storage. So if you look at, since you asked me the question of cost, if you want to transport hydrogen over long distances and large volumes of hydrogen, then pipeline transportation is the most economical way of doing it. Of course, there is a capex investment in it, like for any other pipeline grid to be set up, there is always a capex investment. But again, the pipeline technologies, at least at 100 bar pressure, are technologies are in place. There are companies who are offering pipelines for pure hydrogen transportation. Hydrogen, of course, as we all know, can be transported in the form of natural gas also, as a mixture with natural gas up to about 18%. Uh, but that is better used when you want to use the mixture as such. Not a great idea to eventually separate it out at some downstream application. So in terms of cost for large volume, long distance transportation, it would be the pipeline transport as the most favorable one. The second one is the compressed gas as of today, because that technology is quite mature and these cylinders are being produced in very large numbers. So the economies of scale have already come in. And so the costs for the high pressure cylinder transportation, I believe, are the lowest as of today in amongst all the other means of transportation. The cryogenic forms, this technology is also looking very attractive now. And with scale coming in, I believe that also will start looking very attractive. There is a price to pay for transporting hydrogen in any form. Okay, so there's no two ways about it. It's not, of course, going to come for free. There is a significant cost associated with it, but the technologies are in place and the cost will come down as the economies of scale kick in. And to some extent also, if localization of these technologies happen in India, again, the cost will start coming down.
Great, Mr. Lele. There could and there are multiple questions coming to me in my mind, but then I'd put it to rest for a while and would move to Malhotra sir. Malhotra sir, you have been in the industry longer than anybody else, and you have done notable works in hydrogen segment. So maybe you are the most suited one to answer this. Is what are your views on in your views? Does India have potential to be a global hub for hydrogen? Because in one time we were talking about India being a refining hub, and we are today. In all senses, we are refining hub today. So similarly, do you see a potential in India to be the hydrogen hub in a similar fashion? And if yes, what would be three critical policy enablers which will create hydrogen ecosystem in India? Over to you, Malhotra sir.
Raman, first of all, I would like to, understand when we are talking about hydrogen hub, are we talking about only green hydrogen or we are talking about overall hydrogen?
Green hydrogen. We are green hydrogen. Green hydrogen. Yes.
You want only green hydrogen? Then I have doubts. If we want to become a hydrogen hub, we should start talking about hydrogen economy to start with. If we start talking only about green hydrogen, I think we will be waiting for the cost of green hydrogen to come down, which will be a decade away at least, if not more. So if we talk about hydrogen economy, because I was also looking at figures, if you want to consider that India has hydrogen hub in terms of exporting hydrogen, you mean that perhaps,
Yeah.
India's electricity, I was looking at that figure today, that the power generation in India by 2026 is estimated to be around 620 gigawatt, out of which 38% will come from coal, 44% from renewables. That's one study. The Central Electricity Authority estimates for 2030, when we talk about 817 gigawatt of electricity requirement. And even if we have by 2030, 500 gigawatt target achieved from renewables, we'll need about 35% from fossil sources. Now, if you mean that we will use green power which is coming from renewables to produce hydrogen and export that hydrogen and continue to use thermal electricity or fossil fuel based electricity, coal based or gas based or whatever it is, I think the answer lies that maybe, should we be doing that? You are also committed for carbon intensity also, and converting that to hydrogen and continue to use electricity, fossil-based electricity, I don't know. So I personally feel that if we have to ultimately become hydrogen hub, which may not be 2030, and if we have to, continue to push for renewable power in a big way in this country, you have to allow all colors of hydrogen to start with. Unless you do that, you will miss out on creation of the infrastructure for hydrogen. And if you have to wait for hydrogen, green hydrogen to become affordable and also surplus enough, I think we will miss the bus. So you asked for 3 policy, initiatives which are necessary for creating that. So first would be, I think that we should support the PLI scheme for electrolyzers. There's no doubt about it. But at the same time, we should support infrastructure projects, which is very important for hydrogen. Mr. Lele mentioned about pipelines, which cannot be done overnight. You cannot be creating infrastructure or local manufacturing for high pressure hydrogen storage systems or transportation systems, which will only make it affordable for transportation of hydrogen. You cannot overnight create demand centers for hydrogen. And unless the hydrogen is affordable, nobody will use it. Unless you force refining sector in public, ways, they will reluctantly use 10% if you push them to a wall that they have to use. So my view would be that we should be supporting all forms of hydrogen, not only green hydrogen, and create infrastructure on a fast track method. Allow blue hydrogen also. If you convert your electricity requirement from coal-based to green power and use coal gasification with biomass gasification, what's wrong in it? And capture that carbon dioxide and use CCUS technologies which can be developed in next few years. So I personally feel that the green hydrogen, which you are talking about, will have to piggyback on blue hydrogen at least for 10 years. That's my view. So I feel that all forms of hydrogen, hydrogen is colorless. So let's not talk about color at this point of time. Let's only talk about hydrogen economy, not about green hydrogen economy. So that's what is important. The second point is that the first is that we should allow, infrastructure support like PLI schemes for various infrastructure projects also, or whatever, whether hydrogen compressors or hydrogen cylinder manufacturing. The PLI scheme should give encouragement to those also, like electrolyzers. The second is that you should allow and focus on blue hydrogen also in the period till such time the green hydrogen becomes affordable. The third point, you said 3 points I should mention. The third is encourage R&D for increasing the efficiency of electrolyzers, taking up projects on improvement of the efficiency of electrolyzers, new technologies of electrolyzers, and also to produce green hydrogen in more innovative ways by photoelectric, chemical hydrogen production or biological hydrogen production, etc. You cannot be only relying upon solar and wind power generation to produce green power or green hydrogen. So I think these are the 3 policy initiatives. One on, allowing PLI scheme to be including the infrastructure related projects of hydrogen. And second is to allow and encourage all kinds of hydrogen in the interim period, blue hydrogen particularly. And then third, encourage R&D to develop innovative methods of improving efficiencies or creating new ways of producing green hydrogen. Okay?
Fantastic, Malhotra sir. And I believe only such an experienced person could respond in the manner you did. Actually, we should not talk only about the green hydrogen. We should start talking about low carbon hydrogen and not the green hydrogen, because low carbon, yes, low carbon we need to, because we also need to meet net zero commitment and all. So low carbon hydrogen is will be immensely helpful. But then
Raman, sorry to interrupt. Raman, can I add further? Just a minute, a point which comes to mind, that India is also to look at affordability, energy security and affordability. Now, if you can produce low-cost hydrogen from domestic coal, which will become surplus as we move to green power, I think why waste that source? Create gasification technologies which are available and encourage fast-track development of CCUS technologies. Laboratories like, Mr. Lele is heading National Chemical Laboratory, and IIT Bombay has already created a center for CCUS kind of technology. And I think if we emphasize on those kind of things, Reliance is, Mr. Pandey is here, Reliance is actively working on carbon to chemicals, So those kind of technologies will allow even the coal gasification, which can be done with co-gasification of biomass. Biomass is also, will give you green factor into that. So I think this is important, that we should not miss on energy security from domestic sources and also the affordability, which is very crucial for a growing economy like ours. Okay.
Correct. No, I agree with you, Malhotra. But the only point I would like to bring to the notice of the House is still like hydrogen, your CCUS technology is also evolving. And that, as of now, maybe a bit costlier, but as we go along, the cost of CCUS will also come down. And this will, and that is my presumption, and you are free to comment, Malhotra sir, that with this, we would also strike a more stable geopolitical scenario. Because if we talk of low carbon hydrogen, then the Middle East, who is the energy supplier of the world today, they might continue to remain in a dominant position as we go along. So and that we have seen that equation working perfectly well. So so that also would not prove to be a challenge. The geopolitical scenario could also remain the same where we are in. So that's a great thing to hear. So and encourage R&D. I think you yourself have been pioneer of hydrogen R&D. So I take that point. Great. I would now look to, has Mr. Sharma joined yet or not yet? Mr. Sharma,
yes,
are you there?
I have joined. I have joined. I am just traveling in the car, so there might be some disturbance. You can go ahead.
Okay. And are you expecting to reach the destination in next few minutes, or you will be
no,
there? Because then I can wait. Otherwise, we can.
I think we can start because it will take time. Half an hour it will take.
All right.
Yeah, so
All right.
Mr. Sharma is on. You can ask him question.
Great. So Mr. Sharma, as all of us know, that refinery and fertilizer sectors are being seen as the low-hanging, large demand centers. And same is the case with blending hydrogen with CNG and PNG, and you are present across these value chains. So, however, considering the current technical and commercial readiness of all these sectors, which all verticals are likely to opt for large scale green hydrogen implementation? And when I say large scale, means not the pilot scale, a large commercial scale I am talking about. So amongst these, which ones you believe would take off first? Or if not amongst these, which segment of hydrogen you believe would take off very quickly?
In my view, if you see, of course, there is a technological and commerce. Yeah. Am I audible to you clearly?
Yes, yes, you are audible, sir.
Okay,
Yes, yes,
okay.
quite clear.
So
Go ahead.
okay, so regarding the demand, if you see the largest demand, which is going to the industry, especially refineries and fertilizer. If you see the chunk of this, more than 90% of hydrogen which is consumed in these sectors. So if you are going ahead with the decarbonization of this sector, these two sectors will be taking a largest chunk of industrial demand. Apart from the demand will be coming some from the steel, and future the power industries are also being targeted. You already knows that the government is already planning a policy regarding replacement of this gray hydrogen, whatever we are using in both refinery and fertilizer industries, through the green routes, especially utilizing the solar and wind installed and for installing the electrolyzer at this location. So so they are already coming with these such policies, and policies is expected, I think, within the next couple of months. What government is going to give the targets, maybe a 10% or 20% or 30% in next 5 to 10 years. So in my view, the refineries and fertilizer sector will be the largest chunk for decarbonization in terms of green hydrogen. This will come up in the largest way.
And you said it will be pushed by green hydrogen obligation, which we all are expecting to come in soon. But
Yes.
then I would refer to the point of Malhotra sir, and Malhotra sir was saying that GHO don't expect GHO to do wonders for us. So it will create certain demand, but this should not be pushed through GHO, because it should be based on commercial and technical readiness, and not just by the stroke of the pen. So,
And
any
that is
view
right.
on that whether
Uh,
GHO? Yeah,
it is
please.
like a chicken and egg situation, right? If you if you do not create a demand for the green hydrogen, okay, so there will be no involvement of the investment in the in this market, because you have to first create a demand, because right now there is no demand of hydrogen, especially with respect to green. Why? Because the technology is not yet mature. If you are seeing our alkaline is somewhat it is mature, but still the lot of work is going on to improve the efficiencies to reduce the cost. At this present, the green hydrogen is costlier. That's why people are not opting for converting it to green hydrogen by themselves. Okay, so nobody is going to put their money which is costlier, right? So the ecosystem has to be created. If you have to decarbonize, either you have to have a tax on carbon, okay, then only the people will come, right? Or there's some policy from the government for pushing that these industry sectors should reduce carbon emission by, let us say, 10%, like what is happening in Europe. They have these guidelines, and because of that, they are now pushing more on green areas like biofuels. They are going more for investment, solar, wind. It is going, and you already know that the RE power cost through solar and wind has reduced considerably after these initiatives, right? Solar has, I think, in last 10 years, it is reduced by more than 90%. So the similar kind of push has to be there for green hydrogen. Otherwise, it will be very difficult for accepting or pushing more investment for R&D of this technology if the demand doesn't come. So GSCO definitely will not do wonder, but it will create an initial demand, right? Initial demand, initial investment. So to scale up the investment and improvement of the technologies, and then once it is set up, all manufacturing companies will be cheaper to buy electrolyzer technology in India as a Make in India initiative. As you are aware that Indian Oil and L&T already has gone for tie-up for electrolyzer manufacturing in India, right? So this is based on one of the reasons that we are considering the largest demand based on GSTO commitment. Otherwise, we haven't gone for the green hydrogen because it is very costly at this moment. So some push from government as well as some intensive are also being given by the government in terms of PLI for electrolyzer manufacturing in India. So this type of initiative definitely will help to boost the investment in green hydrogen. because
Great.
that it will
Yes, please go ahead.
it will come very it will not come at the earliest. At this time, the major chunk of hydrogen which is being consumed is in the refineries and fertilizer only. If you see overall demand. So until and unless there is a policy, there is some push, nobody will go in the green hydrogen.
Great. No, I agree with you that the majority of the hydrogen currently consumed is about 6 million ton is consumed by refineries and fertilizer units, which
Yes,
itself is a large demand. And I also agree to your point that this GHO will give sufficient push to transcend from,
yes,
say, pilot scale to commercial scale, and then the industry.
yeah.
Mr. Sharma, and if we intend to take the benefit which hydrogen industry brings to all of us, then we can't ignore MSME, right? MSME,
Yes.
if we intend to derive the maximum benefit, MSME has to be there, and role of MSME in the hydrogen value chain has to kick in. So, any views on how do we make MSME, and or how do we bring in, how do we rope in MSME to leverage this hydrogen development and all across the hydrogen value chain?
Actually, all this will come in picture once the demand is created. Ultimately is because demand is there. Okay, hydrogen demand is always there, but it is a gray hydrogen, right? Gray hydrogen. So once you push and create a aggregated demand by combining the industry hub, like if you have a lot of fertilizer and refinery plant and steel plant nearby. Okay, so you create a hub model. You bring a commercial plant there, right? So um, and once the demand is created, the people will able to interest. People are interested to invest in because there is a offtake agreements, right? They know that yes, these companies are there who will decarbonize their sector and they have a long-term demand. Then automatically, lot of industries with respect to electrolyzer manufacturing, your electrolyzer manufacturing has, I think, around more than 800 or 900 components. Okay, it is not just an electrolyzer. It you have transformer, you have rectifiers, you have associated equipment, right? So that will automatically start generating demand for various MSME sectors, and they will come into the pictures.
Great. And amongst these MSME or across these value chain, any
Mhm.
SME enable and where MSME can quickly have role, any such value chain would you like to mention?
Especially in the parts like the transformers, the rectifier associated with the electrolyzer equipment that is very well manufactured in the countries, right? So they have to just tune or modify to that standard up to the electrolyzer. So these sectors, many companies can work, especially in India. The associate ancillaries
Great.
equipment, which is associated with the electrolyzer. Of course, the stack part is, of course, its stack part is quite critical. So that will not be, that will be done by the major players, right, who are building the electrolyzer. But apart from that, I think in electrolyzer setup, apart from that, all ancillary equipments, you have 800 components that can be manufactured through various emissions.
Right, right. And it is and you believe the technology which needs to be developed or technology which these MSME guys needs to have have fruitful interference in this hydrogen value chain that exists within our MSME system. Isn't that
Yes,
correct?
yes, yes, this is already exists. It's only the only electrolyzer stack part, which is required a technological advancement, right? So a lot of work is happening like PEM or the alkaline or SOFC. That heart of the plant that is stack that is different. But apart from that, all other ancillaries are very well developed in the system. They have to just integrate with the system.
Great, thank you, thanks, Mr. Sharma. Great insights. Enjoy your ride. And
Thank you.
now I would go to Mr. Pandey, and Mr. Pandey, we all know that the size of investment which Reliance has committed looks like to be the largest one, not only probably in India and probably many other parts of the globe also. So the largest size of project which we might be talking about could be the company you come from. So what I would believe that the audience would like to understand that uh, what are the key enablers you are looking forward for creating such a large scale green hydrogen infrastructure? Your views on that, Mr. Pandey?
Yeah, thanks, Raman. So first of all, I mean, we are all in the infancy of, as Dr. Matra said, of hydrogen economy, right? And when you are starting from such a situation, there is a lot you have to do on the ground first. First, you get your hands dirty by looking at let's say smaller projects, because although let's say the hydrogen has been used in industry for decades, right? But the kind of use of hydrogen we are talking about is very different kind of use, right? I mean, right from industry to mobility to electricity generation, there are various aspects of it, and which will require various elements of the hydrogen value chain, or let's say the various elements of the hydrogen economy to come together and literally prove that the hydrogen is a really viable energy vector for the large economies to be taken up. Now, obviously, from an industry point of view, our single agenda is always to bring the best of the technology at the most affordable cost. So, although you need to start from building the infrastructure, using this, let's say, smaller project which can prove and bring the ecosystem together, but you have to ultimately go to the large scale, the same scale what we are using today in the fossil industry to achieve the cost targets, which can gradually replace the the various energy vectors what we are using today. Now, having said that, as I said, the industry has been using hydrogen in large quantity. All of us, as an audience and panelists here, we know that. But to enable various applications, especially on green hydrogen, based on the green hydrogen, there are a few things which we need to learn, we need to prove on the ground, and that most important will be, as Dr. Lele was talking about, the hydrogen supply chain itself. So, starting from, let's say, the hydrogen production, which obviously comes first, but I would go a step, back and upstream of that, looking at the renewable electricity itself, right? So using electricity for the electricity demand is one case, but using electricity to generate green hydrogen, so-called, is another thing. Because that would require you to ask whether I am doing a co-location of hydrogen generation, or I'm moving the electron to some other location and then generating the hydrogen, because that has an implication on the supply chain itself. There are advantage and disadvantage of both these modes, and then obviously making this technologies, right, making this various elements of the value chain cost competitive, bringing it to the cost where it can compete with the existing energy vectors. And we are working on all elements at once. As in a couple of our last AGMs, our chairman has already declared that our whole, let's say, the whole business model for the new energy is that we start from solar, to generate the green electricity, and then obviously use that green electricity by using the electrolyzers to produce green hydrogen. And then the two other items would be to store the electricity, if there's an excess electricity, to store that electricity at a grid scale, or even for the mobility sector. And then also use the hydrogen appropriately in fuel cell for the mobility sector or the stationary. Now, all of this have to come together, because as Dr. Malhotra was talking about, let's talk about the hydrogen economy. We are not just simply talking about green hydrogen because everybody just stuck to, to that single point. It's about, how are we going to do this various economic activities. Obviously, many of these economies like India, or, any economies you pick from the globe, they all rely on different activities. Use of hydrogen for the materials, as a fuel for heat, or for mobility sectors. There are various applications. We all know that. And what we are trying to do is like trying to build the scale in such a way that we can achieve the best cost efficiency in each of this part. Because more than 60% of the cost of the green hydrogen is going to be the green electricity cost itself. So reducing that cost, then the cost of the electrolyzer, the capital cost of that, improving the utilization of those electrolyzers, then obviously reducing the supply chain costs, and also promoting the various end use of this hydrogen. So we are working on all these elements at once, because hydrogen economy has been has struggled always with the problem of the chicken egg, where the demand and where the supply would come. And we are trying to tackle all this problem at once by looking at a large scale demand, which we as a diversified business can handle it, probably better than others. But the economy of scale is a very important aspect if the hydrogen economy has to realize its real potential. Otherwise, it will be just let's say a few pilot projects and those kinds of demonstration which has been happening across the globe for decades. But for the real hydrogen economy to be realized, we will have to really do things as we call business as usual in the energy business. So I would stop there, Raman, and happy to expand further if needed. Thanks.
Thanks, Mr. Pandey, and I really appreciate the point that it has to make commercial sense, because without that, some push can be given in terms of, as we all have spoken about GHO and all those. So some push can be given, but it has to survive on its own, and the commerciality needs to work before we go for large scale implementation. So agreed on that. I would now move to Mr. Ahlawat. Naveen, I have always known you to be the most active promoter of the new ideas and technologies, and that is why I know that you are handling too many portfolios which are all new developing. So maybe you are the best one to answer what I am going to talk the agenda now. So as we all know today, one of the major reference for green hydrogen is gray and blue, as we have heard right from the first speaker, Naveen. We have heard that we are talking not only about green hydrogen, but creating a low carbon hydrogen. And we have gone on talking about that. Please allow blue hydrogen, please allow gray hydrogen also to the market, and all sort of arguments. So, and our reference is gray and blue, which we intend to replace by green hydrogen. And there is a substantial cost difference, as we all know, between the gray, blue, and green, and maybe other colors of hydrogen. And CCSU, we all know again that this is looked at as a major decarbonization pathway across the globe. Right. So, and in this, but as of now, again, CCSU cost is also seemingly looking to be prohibitive. In such scenario, how do we develop institutional and financial mechanism? Because here most of the I have heard our speakers also, and from the other analysis and reviews, we know that the cost and the developing the cost mechanism and the institutional mechanism to support it is very important. So how in your belief, how do we develop institutional and financial mechanism to bridge the gap between different colors of hydrogen, especially in India? Naveen, over to you.
Thanks, Raman. Thanks for the question, and it's a pertinent question related to this subject. See, we at Jindal Steel and Power, we are already successfully running the world's first coal gasification-based DRI plant, and this plant was commissioned in 2014. So this was the first direction in basically the first step in the direction of decarbonization by any industrial house in India, right? There are so many, there are so many business houses still on the drawing board, but the plunge was taken with so many things in mind. First is to completely get devoid of the volatility of the coking coal, for which we are 100% dependent on big players like Rio Tinto, BHP Billiton, Vale. Second was basically how we can make the entire steel making process greener, right? And third one is basically to make it cost competitive. So it was based on the idea that how we can gasify coal. We all know that yes, India has got close to 327 billion tons of coal reserve, and out of that, close to 160 to 170 billion tons are they can be recovered. So if we can just go with the 1 billion ton average consumption per annum, so we have still 40 to 45 odd years we can go ahead with this. So I strongly believe that this path from gray hydrogen to green hydrogen, it will go in step. So the first step or the first milestone will be to take a transition from gray hydrogen to blue hydrogen. We right now, as we speak, we are capturing 2,000 ton of CO2 in both our coal gasification plant and our DRI, that is a sponge iron making plant. But what we are doing, we are capturing the CO2, but then we are releasing in the atmosphere. So now we are evaluating different options how we can utilize this CO2, because this CO2 is enriched. CO2 having a concentration of more than 99%, right? So we can easily use this CO2 to make chemicals like methanol, ethanol. We can use this CO2 into biological uses, wherein we can make algae out of it. Then maybe further processing downstream, we can make algae oils, peptide, protein, amino acids. All the value chain of algae. And then the third one is on the mineralogical side, where we are evaluating different options wherein we can pump this CO2 in the mines. So I think these are the steps which we are taking, and these are the stuff which are evolving in nature. It is not going to happen overnight. It is going to take time. Step by step, we have to go ahead. So this is the first stage. Once we cross that, then I think it will become pertinent for us to go from blue to green. Because right now, if we see from the economical point of view as well, I think the coal gasification with CCU, that is carbon capture utilization, to us, I think this is the biggest. It has got the most economical sense right now if we compare with the green hydrogen. If we add in this value chain, the value of the gas, the value of hydrogen will come somewhere around 1.2 to $1.3 per kg, which I think is amazing economic. If we can use this hydrogen for anything. So I think for us, we are actually going very fast, very aggressive, that how we can utilize the low-hanging fruits, the quick wins. And for us, these are the quick wins, wherein we can utilize this hydrogen. Mind you, hydrogen, we are not going to make hydrogen and sell in the market. We are a completely user of hydrogen. We can use this hydrogen for making that reduced iron. Instead of reducing iron oxide with the help of synthesis gas, that is S2CO, we can reduce the iron oxide with the help of hydrogen to the sponge iron, that is Fe. But again, this is also a technological advancement or maturity which we are going to see in years to come. Because as we speak, if we use 100% hydrogen to make sponge iron, it is a 100% endothermic reaction. So the temperature will fall down, and we have to clearly see how the chemical kinetics and the thermodynamic behavior it is going to see in the overall furnaces, the shaft furnaces. So I think there are a couple of companies in Europe, especially in Sweden, Norway. They have started the work. One of the companies like Green Steel, they have already announced putting up 2 million ton of sponge iron making with the help of 100% hydrogen. So I think a lot of advancement we are going to see right now. The tried and tested thing which we have seen with a couple of experiment, the lab or the commercial experiments, where they have clearly said that yes, with 20 to 30% hydrogen and rest maybe synthesis gas or natural gas is what they have come up with the final outcome. But again, the results are going on with the help of green hydrogen, and maybe in a couple of years, maybe 2 to 3 years down the line, we'll be able to see that where exactly we have to move forward.
Great. No, and I think your point that we have to see the things commercially. And as you took example of methanol, and methanol, again, it's a great means not only to decarbonize or utilize hydrogen, but also to say get carbon utilized, which we might capture from other industrial units. So if we start looking at things in synergy, I take your point that it would start looking better commercially and technically. A great point. Thanks, Naveen. Now coming to Mr. Dev. Uh, Mr. Dev, do you believe that hydrogen as the means to store energy is competing with battery technology? Because whenever we talk of hydrogen, people start talking hydrogen as a means to energy storage, and then the competition between these two start getting discussed. So, what would be your view on whether these two technologies are competing, and if no, and if you see that these two technology complementing each other, uh, how do you see both these sectors individually and in consonance? Your views, please, Mr. Dev.
Sure. Thank you, Raman. I think you've phrased it already, and the esteemed panelists have also covered it. Hydrogen today, on a commercial basis, doesn't compete with any technology, right? So let's be clear about that. If we have to develop a hydrogen economy, we are not doing it for the sake of hydrogen only. We are doing it for the sake of a path to net zero. And in that pathway, hydrogen has a very important role to play because it is complementary with other clean technologies that will exist and work closely with. EVs and electrification is one. Obviously, RE is the other. Green hydrogen, of course, when it will become viable, will be a perfect complement with these technologies. On storage, again, so we're talking about different maturity cycles here. At the right time, yes, it will fit in beautifully. At the moment, the technology probably is not mature to compete with battery BESS at a grid scale battery storage today. Both have their pros and cons. Again, also they have their different benefits, right? At larger scale, hydrogen will probably overtake battery. But again, that depends on how the configuration is set up at a plant. So it's not a simple answer. And it is, I think, the question should be about the future rather than today. Yeah, because today we know what the answer is.
Correct.
Right? So yes, there is a complementarity role, and it has to be because they are important for India's path to net zero.
Great. Thanks, Mr. Dev. And I take your point on complementarity. And what I would also like to understand from you, in your views, do you think that both these technologies would be used for different purposes and coexist and probably complement each other? Because if I take just mobility, what usually I see getting discussed is that your battery technology or battery mobility could be utilized for probably intra-city movement, while for the long haul, we might have to rely on hydrogen or probably LNG. So that there is a synergy between these two. So do you believe that this sort of coexistence will prosper in future, or any different diverging views?
Right. So the way that I would like to sort of respond to that is, why are we talking about the different use cases? We're talking about it because some will be viable, some may not be as viable, depending on the different use cases, right? Our view, not just as FTI, but also the India Hydrogen Alliance that we are part of and lead, our view is a lot of these questions will get answered by the people who run the commercial scale projects and who take the decision of which technology to use. So it's not a simple answer. This is not, you don't have to choose between firstly electric and battery or hydrogen. You don't have to choose between PEM, alkaline, electrolyzer, or solid oxide today. It's not for the ecosystem to decide that. It's for the project developer who takes that decision to make that technology choice, right? Take it at a municipal level. If the municipality wants to decide they want to run part of, let's say, transport as electric and part of it as hydrogen, they will make the assessment, and they will make the financial assessment, the technical assessment, and some of these studies have been done, right? So there is a bit of consensus, but we don't want to say we can answer for everybody right away, right? And it shouldn't be that way. Right? So as IH2A, what we have focused on, I think, let's have the environment. What are the key requirements for the hydrogen economy to come about? The technology question need not be answered by everybody. What we need to decide is what is the next stage for commercialization? What is stopping that? And if you see the example, both in Europe and other parts of the world, moving from R&D stage to commercial scale projects is the key. And one way to do that is to aggregate demand, co-located production and demand. And that's the idea of hubs or the hydrogen valleys in a European context that's currently being undertaken. It's a plan we have also presented to the government, and that's been well received. But that's an important step, we think, that's important for the ecosystem to take. Sorry, there's a bit of echo. I have a network issue, I believe.
Great, no problem. We have heard you clearly, Mr. Dev, and appreciate your point that let us not try to respond to every question. Let us leave it to the concerned agencies and people what works for whom. Agreed, and that I think makes sense. So. Mr. Lele, I am aware of your time. Next question, which is very critical, and I would want my audience to be benefited by that. So the one discussion which I would like to bring to you is India is high on biodegradable resources, right? Biodegradable resources, because it's a agrarian economy, so we are high on biodegradable waste. So do you see biohydrogen production using agro residues large opportunity for India from the technology perspective and from the resources perspective we have?
Yeah, it's a tricky question, Raman, because of multiple facets that one needs to consider to answer your question. So first and foremost, bioresources, yes, theoretically are available, but they have to be collected, aggregated, and used. So there is a supply chain that needs to be put in place. And that's not a trivial supply chain. It's also, as any renewable, seasonal bioresource that is available. So that needs, that has its own issues of storage and so on and so forth. So one is the supply chain issue that needs to be sorted out. The second is that, any carbonaceous material, whether it is biomaterial or coal or natural gas, anything that contains carbon and hydrogen, right? I think if you just get rid of the carbon and load all your costs on hydrogen, then I would worry on two aspects. One is, what is the cost of that hydrogen that you are producing? To take a simple example of methane, for every 16 ton of methane, 12 tons are carbon. So do you want to really get rid of it in the form of CO2 and emit it and load all that cost on the remaining 4 kg of hydrogen? And would that be viable? That is question number one. And the same goes with biomass as well. Question number two is that that carbon is actually a useful molecule, is a useful atom, and why not make use of it rather than making it into CO2 and releasing it out? What I mean by that is with either coal or biomass, when you gasify it, you will get a producer gas, a gas that is quite active in terms of its in terms of being a chemical, right? And you can convert that into liquids, chemicals, fuels, whatever type. So in which you are valorizing that carbon. So if you only focus on hydrogen, it may not be the smartest way to do it. Okay, so gasification of biomass and using that carbon to convert it into either chemicals or fuels is probably a smarter way of doing it rather than releasing all the carbon dioxide. Uh, of course, you can use the carbon dioxide, convert it into methanol and so on, but there is, remember, there is a cost associated with all of that. And you don't want to load all that cost on hydrogen. Similarly, you can uh, take that CO2 and sequester it, right? And again, it's not, doesn't happen for free. So whether you sequester it in saline aquifers or in basalt, uh, it is not free. So again, are you loading all that cost on hydrogen is a question that you need to worry about. Okay. Lastly, if you want to release all that carbon dioxide out, then of course it's not blue. In the case of biomass, you can be forgiven because it is, you can argue about a carbon cycle. So you can take all that carbon, release it back and not worry about affecting climate change. But again, it's not a very smart thing to do. So why not use biomass related technologies which can also valorize the carbon? So for example, if you were to produce biochar, or if you were to use that carbon in some form of a soil nutrient, okay, and make an effort to increase the soil organic content of carbon, I think that's a much higher value and use of carbon, both from an environmental perspective and from an economic perspective. So to have a short answer to your question, first of all, it is not a trivial answer, and this is not a trivial question. Second, if we restrict discussions only to biomass, then I would look at adopting technologies which can also valorize the carbon in one form or another. And you could either convert that into biomass, biochar, or you could convert it into a soil nutrient that can increase the organic carbon content of the soil, number two. Number three, of course, you can gasify, collect the carbon in the form of either CO or CO2, and then convert that back into some valuable liquid fuels or chemicals. And last option is to release all that CO2 back without worrying about the fact that you are causing adversely climate change, because that carbon is anyway fixed in the biomass in the first. But that would be my absolute last option if nothing else works out. It's worth trying all the other options that I mentioned before you just simply release the CO2 back in air. There are other technologies, of course, of converting biomass into biomethane. You can then use the biomethane as such, or you can convert it into hydrogen further by either reforming it or by pyrolyzing it. So there are multiple options of what you can do with the biomass. The only thing I want to say is that use technologies where you can valorize the carbon. Use technologies where you can use the carbon in one form or another. And I think that would be the more meaningful way to use the biomass reserve for making hydrogen.
Great, thanks. I think that you have given a very, very wholesome response to the discussion agenda. And more often we tend to talk about our biodegradable resources and how we could leverage. But I think the challenges you have highlighted of logistics and the cost increase, and not looking at it again, as Naveen also highlighted, that not looking at it in isolation, but look from the perspective of valorizing the carbon also generated from other units. So that's, I think, a great insight, Mr. Lele. So thanks for the response. And now again, I would like to come to Malhotra sir. Malhotra sir, as we discussed briefly, that there is a public perception of the safety issue. So what measures would you suggest to counter the public acceptance challenges of hydrogen fuel cell in cars? Now I am coming specifically to hydrogen in mobility. So how could we counter the public acceptance challenges of this hydrogen fuel cell cars?
Raman, I think Mr. Lele very rightly said in the earlier, question answer session that hydrogen is pretty safe. People had reservations about CNG. I also remember when CNG was introduced, people had reservations about that. And same thing may happen around hydrogen, but let me tell you that we need to create public awareness through various, the auto sector will also do it, and various other government people or the hydrogen suppliers will also do that. The hydrogen is even safer when people say, because if it leaks out of the tank, it will straight go up. It being a very light gas, it won't stay near the ground. So some people say it is even safer than motor gasoline from that matter point of view, but it is explosive. So you have to only ensure that you use the right kind of materials for storage tanks, etc. when you're using high pressure storage cylinders. But technology, composite materials for type 4 cylinders, etc., which allow high pressure storage, I think that's a proven technology now. And we have seen, various issues of fires, etc., in electric cars. But I don't hear anything, because USA, particularly in California, they've been running for more than a decade, several hundreds of cars, fuel cell cars, with high pressure storage at 700 bar or so, where nothing has been heard of. So only thing is that kind of, information has to be disseminated amongst the masses. So that's about it. So the only thing is that we need to follow the international standards, and we need to adhere to those, and strict adherence is important. The PESO is there. So PESO has been even more conscious in our country. They don't allow 700 bar storage and at this point of time, but we will have to persuade them, because that's the way to go about it if you have to have longer range for vehicles. And as far as this is concerned, mobility particularly, this will happen not in cars first. In India, we estimate and anticipate that hydrogen will first come in use in high, heavy-duty vehicles like trucks, because they are not meant to, when EV revolution comes in two-wheelers or cars, it is not going to catch up the same in trucks, because trucks are supposed to carry loads and not the battery load, So hydrogen composite cylinders, high pressure storage cylinders will come into play, firstly in trucks, which will be moving more on highways. So that will install confidence in people by the time we are ready to use hydrogen in our cars. I think that's the way to go about. As far as the public perception or issue regarding safety.
Yes. I think you have said the correct thing, that let hydrogen be used by the people who believe in it, and then there will be further mass application of it coming through. I think that's the correct approach, Malhotra, and thanks for the insight. Mr. Kaul, I see the clock ticking. Do we have 5-10 more minutes, or we need to get off?
You can have 5 more minutes, sir.
Okay. And do we? I don't see any provision for open house questions. So do we do away with that? I'll go with 5 minutes discussion more, but then we don't have provision for open house questions. Isn't that correct?
We do not have that provision.
Great. Thanks. So then, as maybe I would come to Mr. Pandey. Mr. Pandey, you have spoken about how do we create synergies and how do we make this ecosystem work for larger projects. Would you like to comment on the ways and means to improve the competitiveness of hydrogen in specifically mobility sector? Because mobility sector is the one which has really large potential, and if it becomes competitive in mobility sector, then I believe things will start moving around. So would you like to comment on how do we make this competitive in mobility sector?
Yeah, Raman. So as even Dr. Malhotra was talking about earlier, the competitiveness. See, what we are talking about is the future of mobility, right? So the future of mobility itself, we have to look at it from the powertrain point of view. When we are talking about, let's say, hydrogen, a lot of people immediately consider the hydrogen fuel cell, which obviously, if you're talking about hydrogen fuel cell, which produces electricity, we are talking about the electric powertrain. But then we are talking about, let's say, other aspects of hydrogen mobility. One has to also consider that the hydrogen can be directly used in the internal combustion engines, right? So the competitiveness, looking at the future, and we all have been in some ways, the panelists here, we've been talking about that. We have to be very realistic. What we are talking about. It's not that we can switch up, turn on the switch and then everything will, turn to a hydrogen economy. So I would suggest ultimately efficiency, wins, and the future is obviously going to go to the technologies and the sectors which are more efficient. To get the same job done if we can consume lesser energy. Now, two-wheeler, three-wheelers are always going to be on the electricity, directly using the electricity through the battery, because as of now, at least that seems to be very efficient. But then as you move to the long hauls and heavy duty mobility, going upwards of, let's say, probably 18 tonner or 15 tonner, and then all the way to trains, ships, and etc. Clearly, the battery, the reason for the kind of energy you store in every kg of battery is far lower than what you can get from the hydrogen as an energy vector, right? And obviously, when you're talking about the long haul, that is more important, how much distance you can travel and how much load you can carry. So hydrogen clearly has an advantage there, let's say fundamental principles point of view, but to enable that you have to take a very let's say realistic steps. Now, as I said, we are talking about the future of the mobility, and if it is going to be the electric powertrain, the powertrain itself are not very cost effective right now, whether it is based, the mobility based on the battery or the fuel cell or any other hydrogen, right? So what you can think of, rather than changing that powertrain to the electric powertrain, you can actually leverage the IC technology, and you start using hydrogen there in the IC engines, right? So internal combustion engines. That wouldn't require you to change the powertrain itself, right? That's more important. And then also you can take the existing, let's say the BS4 or BS3, those sorts of vehicles, and you can think about converting them on the hydrogen, right? So many of these vehicles which will still be plying on the roads, you can start converting them to the cleaner option. And then obviously that would help because you do not require a large investment to begin with on the end application side, and obviously you still have to build the infrastructure, but this infrastructure can always be used again when the things move to the fuel cell based mobility. As the technology and the infrastructure matures, as the consumption starts happening from the heavy duty long haul applications, you may start seeing some transition on the passenger and taxi based systems, although it's very difficult when that will happen. It's difficult to predict that, but what you can leverage is that having the battery electric mobility getting developed, and the powertrain for that, the electric powertrain for that can be again leveraged for the fuel cell based mobility. So to make it competitive, you have to go with a multi-stage, let's say strategy, where you see, where is the least barrier. You try to implement hydrogen-based mobility there. Like you can start from IC engine. And obviously the fuel cell based mobility is more efficient than the ICE, but then you need the infrastructure to supply that fuel. So you will have to do it in a stage wise manner. Start at let's say low hanging fruits, such as long haul or even in the marine. So there are various sectors you can start looking at, and the projects are being considered in that aspect as we speak. So I don't see a problem with it. I see the future of energy is a mix of all this technology, and they will adequately, we will come to that point where this technology is automatically fit to their respective areas where they are competitive.
Great. Thanks. I think that's a good insight, Ms. Pandey, and in cognizance of time, but I can't leave the house without asking the question on the regulation, and I would come to the most appropriate person to answer this, Mr. Rao. Mr. Dev, the government has announced few measures to promote hydrogen like PLI, and there are many others. First would be, to what extent these policies are able to help the sector develop, and then if there is more to be done, what should be the appropriate direction to take them forward, Mr. Dev? Quick response.
Yes. So first thing, I think, as Anurag and other panelists have also mentioned, this is not just a technology play. If we are to develop on the hydrogen economy and integrate it with net zero, we are talking about transforming the entire energy and industrial ecosystem, right? So the few announcements that have been made obviously are very helpful. The intent from the highest level of the government, right from Honorable Prime Minister, is also very excellent, because you need political championing of hydrogen. But to really embark on a truly transformative plan, which looks at hydrogen driving this transformation, or at least being a big catalyst, requires a multidisciplinary planning and thinking, and bringing all the different parts of the supply chain and the value chain together. Just an example, I think this issue is too large to be done by, let's say, a single sector or a single part of the value chain. Or I would even say, go to the extent of saying one part of the government, right? This requires multiple ministries to collaborate together, multiple parts of the economy to work together to create the multiple use cases to cover the different parts of the value chain. It is a mammoth task. So I think we need to first acknowledge that and start planning for that complexity. I mean, just an example, if we were to propose a National Hydrogen Development Corporation, for example, right? It should be public-private. It should be cross-ministerial and multi-industries participating there. That's the only way to solve this complex problem of the hydrogen economy. It's not a simplistic, unfortunately, it's not a simplistic step that can be fixed with one or two policy actions. It needs a whole set of policy actions, and they may need to be refreshed every 3 years to make progress.
Great, thanks, Mr. Ray. And looking at the time, I would take a pause here. And as you said, just to summarize the discussion, as you rightly said, it's a mammoth task which we have taken, and we all are, being well-wishers of the hydrogen industry, we have all have taken that as our goal and vision. So, and to do this mammoth task, and thanks to all the panel members who have discussed that we should not only focus on the green hydrogen, we should try to look at the low carbon hydrogen, combining maybe blue hydrogen and all sort of hydrogen, which would lead to eventually lowering the carbon. So, and in terms of creating support infrastructure and giving push to R&D, that itself is a big task in hand. So, and there has to be a multi-pronged strategy. No one firm, no one agency, no one ministry would be able to do this single-handedly. There has to be effort and multi-pronged strategy, which I think we all have discussed. So, thanks to all the panel members and thanks to the audience. I know there would be several questions which would be coming through, but then we would keep that and park that for the next event. Please keep that in your notepads, and we would be back with the next event to you, and we'll have enough and ample opportunity to ask them. So with that, I would thank all the panel members for joining this, and audience for your time. And I'm quite hopeful that all of us have immensely benefited with this discussion. Thanks everyone.